I want you to picture the scene. It's arguably one of the most terrifying descriptions of a natural disaster you will find anywhere in ancient literature.
Absolutely.
You have a storm that hits with so much violence, it literally changes the shape of the land.
Yeah.
The text describes winds that can carry people away, lightning that's just unlike anything previously seen, and earthquakes that are burying entire cities.
And that's just the opening act. That's the noisy part.
Right, because after all that violence stops, the lights go out.
Yeah.
And we're not talking about, a cloudy afternoon or a heavy rainstorm.
No.
The text, this is 3 Nephi, chapter 8 in the Book of Mormon, describes a vapor of darkness so thick that people can't light fires.
Can't light fires.
No candles, no torches, nothing. Just total suffocating blackness. For 3 days.
It's a heavy scene, and for a long time people read that and just thought, okay, this has to be metaphorical. Darkness representing spiritual despair.
Or maybe just supernatural storytelling.
Right, to mark the death of Christ, which is when this event is supposed to have taken place.
But today, we're asking a very different kind of question. We're asking, what if it's a crime scene?
Exactly. If something that massive actually happened on this planet, specifically in the Americas, around AD 33 or 34, well, nature doesn't just forget.
The Earth keeps receipts.
It absolutely does.
So today, we're doing a deep dive into this fascinating piece of research by a geologist named Benjamin R. Jordan. The article is Volcanic Destruction in the Book of Mormon, Possible Evidence from Ice Cores.
And we're going to see if we can find the fingerprint of those 3 days of darkness in the geological record.
To do that, we actually have to leave the tropical setting of the Book of Mormon and go to the coldest places on Earth.
We're going to the ice sheets.
Before we get to the ice, though, let's establish the suspect. When you hear vapor of darkness, as a layperson, I'm thinking supernatural or maybe a really, really bad eclipse.
Sure.
But Jordan argues this fits a very specific geological profile.
It does. And this isn't a totally new idea. Geologists like Dr. Bart Kowalas have pointed this out before. When you strip away the religious context and just look at the physical description in 3 Nephi, it is. Well, it's basically a checklist for a massive, explosive volcanic eruption.
Walk us through that checklist. What details specifically scream volcano?
Okay, let's break it down. The great storm, the intense winds, huge volcanic eruptions generate their own weather systems.
They make their own weather.
Oh, yeah. You have this superheated air rising so fast it creates incredible wind shear. The lightning, that's a classic feature of what we call a dirty thunderstorm.
A dirty thunderstorm. That sounds ominous.
It is. It's when all those tiny ash particles collide in the plume and create these massive static charges. You get lightning that's just way more intense than a regular storm. And then obviously you have the earthquakes.
Right.
That's magma moving underground or the whole magma chamber collapsing.
And the darkness, the part where they can't even light a fire.
That is the smoking gun. Literally. It's volcanic ash. If you have a large enough eruption, and we're talking a major event here, the ash plume can be so dense it just completely blocks out the sun.
And the vapor that puts out fires.
That's likely a mix of dense ash and gases like carbon dioxide, which are heavier than air. They can settle in valleys and just push the oxygen out. You literally can't get a flame to ignite.
Because there's no oxygen to feed it.
Exactly.
So the description really does match the science. It's not magic darkness, it's physics. Now, the logical next step would be, okay, let's just go to Mesoamerica, where most scholars place the Book of Mormon, and find the volcano.
Find the crater.
Yeah, find the crater, date the lava flow to AD 34, and case closed. Why isn't it that simple?
Oh, I wish. Jordan spends a good portion of the article explaining why Mesoamerica is, frankly, a nightmare for this kind of specific work.
Is it just because it was so long ago? 2,000 years seems like forever to us.
For geology, that's yesterday. No, the problem isn't time, it's volume. Mesoamerica is the second most volcanically active region on Earth.
After Indonesia.
Right behind Indonesia, it's part of the Ring of Fire. There are volcanoes everywhere. And Jordan uses this brilliant analogy. He says, trying to find one specific ash layer from 2,000 years ago in Mexico isn't like finding a needle in a haystack.
No. What is it like?
It's like trying to identify one specific cornfield in Nebraska.
Oh, because it's all corn.
Exactly. The ground is just layer upon layer of volcanic material. Eruptions from 8030, 8100, 8500, all stacked on top of each other, all looking kind of similar. Plus, you're in the tropics. Heavy rain, rapid erosion. The evidence gets destroyed or mixed up really fast.
So the local crime scene is contaminated. too much noise, too much erosion.
Right. So if the local record is messy, you have to look for a global record. You need a place where the evidence falls from the sky and just stays there, undisturbed for millennia.
Enter the time machine. The glaciers.
The glaciers, specifically the ice sheets in Greenland and Antarctica.
Okay, for the listener who hasn't spent time drilling in the Arctic, let's break down how this works. How does a volcano in, say, Guatemala end up in an ice cube in Greenland? That feels like a pretty big commute.
It is, but it's all about the atmosphere. See, when a volcano erupts, if it's just a little burp, the ash stays low in the troposphere.
That's where our weather is.
Exactly. Rain washes it out in a few weeks, and it stays local. It's never going to reach Greenland.
So for a signal to go global, you need something bigger.
You need a monster eruption, what we call a VEI, a volcanic explosivity index of 4 or higher. It has to be powerful enough to blast ash and gas, specifically sulfur dioxide, all the way up into the stratosphere.
Above the weather.
Exactly. Once it's up there, there's no rain to wash it out. The sulfur dioxide spreads out like a blanket around the globe, and over time, it converts into sulfuric acid aerosols.
Basically a haze of acid.
A haze of acid, and that haze eventually drifts toward the poles because of global air circulation, and gravity pulls it down. It lands on the snow in Greenland or Antarctica, and because those places never really melt, the snow just piles up year after year.
Like pages in a book.
Precisely. The weight of the new snow compresses the old snow into something called firn, which is like this porous, crunchy ice, and eventually into solid glacial ice. Scientists can drill a core that's miles long, pull it up, and just count the layers back in time.
So they're looking for a layer of dark ash in the white ice.
Well, rarely ash. Ash is heavy. It usually falls out closer to the source. They're actually looking for the acid.
The acid.
Yeah. When they analyze the core, they run an electrical current through it.
Why electricity?
Because pure water is a terrible conductor of electricity. But acid conducts really well. So they're moving down the ice core, measuring conductivity, and suddenly, beep, you get a big spike.
And that spike tells them something huge exploded somewhere on Earth during this year.
Exactly. And this method is one of the best climate records we have. We've used it to track the eruption of Thera that might have ended the Minoan civilization. We can see Roman-led pollution from their mining operations. It's an incredible global archive.
Okay, so the mission seems straightforward then. We have a date, roughly AD 33 or 34, based on the timeline of the crucifixion. We go to the Greenland ice core, look at the layer for AD 34, and see if there's a spike. Spike, plausible. No spike, problem.
That is the mission. But this is where Jordan warns us. Geology is not a digital clock. It's messy. There are ambiguities we have to understand before we can even look at the results.
Why? I mean, if the event happened, shouldn't the spike be there?
Well, there are 3 or 4 big gotchas that make this detective work really hard. The first is just physics. Remember I said the eruption has to be huge to reach the stratosphere.
VEI 4 or higher.
Right. But it's entirely possible to have a catastrophe that destroys a region, just like the one in 3 Nephi that doesn't quite punch through.
So you could have total destruction on the ground, cities buried, darkness for days. But the plume stays just low enough that the ice sheet in Greenland would be totally oblivious.
Exactly. Absence of evidence isn't necessarily evidence of absence. But the bigger problem for finding a specific signal is the background noise of the northern hemisphere.
The Nebraska cornfield problem again.
In a way. Greenland is in the north. The north is just full of active volcanoes. You've got Iceland, Alaska, the Aleutian Islands, Kamchatka, and Russia. These guys are erupting all the time.
So the ice is constantly getting dusted.
Constantly getting dusted with local volcanic acid. It's like trying to hear a whisper from Mexico while a heavy metal band is playing in Iceland.
That is a perfect analogy.
And then you have the wind. Jordan brings up the eruption of El Chichon as a warning.
That was Mexico, 1982. I remember that one.
Huge eruption, definitely big enough to leave a global mark. It put a massive amount of sulfur into the atmosphere, but the wind patterns that year just kept swirling the cloud around the equator. It took a long time to drift north.
So it creates a lag.
A significant one. It usually takes about 2 to 3 years for aerosols to get from the tropics to the poles. So if the Book of Mormon event was in AD 34, we shouldn't be looking at the AD 34 layer. We should be looking at AD 36, 37, maybe even 38.
That's a crucial distinction. We're not looking for the date of the event. We're looking for the date of the fallout.
Correct. And then there's the really scary data point, the mystery of Mount Pinatubo.
Pinatubo, 1991, Philippines. We have satellite footage of that. One of the biggest eruptions of the 20th century.
Absolutely massive. Millions of tons of sulfur dioxide. We watched it spread globally, and yet if you look at the Greenland ice cores, it's barely there.
Wait, what? We know it happened, we know it was huge, but the Greenland ice missed it.
It showed up very clearly in Antarctica, but the Northern Hemisphere record is really spotty. It just proves that atmospheric circulation can be chaotic. If you only looked at certain Greenland cores for 1991, you might conclude Pinatubo never even happened.
Wow. That sets a really interesting baseline. It means finding nothing doesn't disprove the event, but finding something is actually quite significant because the ice is so finicky.
Exactly. We have to have some humility about what the ice actually preserves.
Okay, enough with the caveats. We know it's hard. We know there's a lag. We know there's noise. Let's get to the data. Jordan looked at the major ice cores available, Camp Century, Die 3, GRIP. What did he find in that window, say, AD 30 to AD 40?
He found signals.
Okay, give us the details.
The strongest piece of evidence comes from Camp Century. This is a famous core drilled by the U.S. Army in Greenland way back in the Cold War.
I've heard of this. Project Iceworm, right. They were trying to hide missiles under the ice.
That's the one. They built a whole nuclear-powered city under the ice, but the science they got out of it was incredible. The researchers analyzing that core identified what they call an unambiguous volcanic signal. This wasn't background noise, this was a major event.
And the date.
They dated the layer to approximately AD 37 or AD 38.
Okay, wait. Let's do the math here. If we assume the eruption in the text was AD 34, and we add that 2 to 3 year lag time for the acid to travel,
you land exactly on AD 36, 37. The timing is spot on.
that is kind of eerie.
It is compelling. Now, we have to be responsible scientists. Jordan notes that the dating on these older cores isn't perfect. For Camp Century, the margin of error is about plus or minus 30 to 40 years.
Okay, so strictly speaking, that spike could be from AD 10. It could be from AD 70.
It could be. But the best guess date, the center of the probability curve, is AD 37. It aligns perfectly with the lag time from an AD 34 event.
That's Camp Century. What about the other cores? Did they back it up?
Well, there's the Die 3 core, also in Greenland. It shows a significant spike around AD 47.
That seems a little late, doesn't it? Even with the lag time.
It is a bit late, and the chemistry there is a little weird. It's mostly nitric acid, which usually comes from warm summers, not volcanoes. But the sulfate levels in that layer are double the normal background. So Jordan thinks this might be a volcanic signal mixed in with a melt event, which confused the dating.
Is there anything to back that up? Or is Die 3 just an outlier?
No, it actually has a partner. The Plateau Remote Core, this one's all the way down in East Antarctica, shows a clear volcanic signal at AD 46.
So we have a cluster in the late 30s at Camp Century, and then another cluster in the mid-40s at Die 3 in Antarctica.
Which tells us the Earth was definitely active during this period. It wasn't a quiet time. There were multiple eruptions big enough to reach the poles.
But I have to ask about the one that didn't show anything, the G-Right core. The article mentioned this one was silent.
Right, and the G-Right core is considered one of the gold standard cores. It shows a spike at 81, and it shows a massive spike around 80, which we're pretty sure is Vesuvius.
But in between?
Nothing. Silence in the 80, 30s, and 40s.
How can Camp Century be screaming volcano and GRIP be saying all clear when they're on the same island?
It comes down to geography and altitude. The G core is taken from the very summit of the ice sheet over 3,000 meters up. Camp Century and Die 3 are lower down. Jordan suggests that the G-Ripe site might just be too high.
So the evidence literally flowed underneath it.
That's the idea. The atmosphere is layered. If the volcanic cloud wasn't high enough to blanket the very summit, but it was high enough to hit the slopes, GRIP misses it, while Camp Century catches it. It just highlights why you can't rely on one core as the absolute truth.
So we have global evidence of significant volcanism in the right time frame, especially that Camp Century data. But let's bring it back to the scene of the crime. Did Jordan find any evidence in Mesoamerica? Because a spike in Greenland proves a volcano erupted somewhere, but not necessarily in Mexico.
This is where the story gets really interesting. Jordan points to recent work on the Tacana volcano.
Tacana, where is that?
It's this massive volcano right on the border of Mexico and Guatemala. It's huge, almost 4,000 meters high. It dominates the landscape.
And what do we know about its history?
Well, recent radiometric dating shows that Tacana had what's called a phreatic eruption. That's a big steam and ash explosion, sometime between AD 25 and AD 72.
That is a very specific window.
Yeah.
And AD 34 sits right in the middle of it.
It does, and we have archaeological evidence to go with it. There's a major ancient site nearby called Izapa.
Izapa. That's a famous site for its stelae, the stone carvings, right?
Yes, very significant site. And right around this exact time, early 1st century AD construction at Izapa just stops. The civilization takes a massive hit, and excavations show the city was inundated by mud flows.
Mud flows. In geology terms, that's a little hard.
Exactly. It's what happens when you mix loose volcanic ash with heavy rain. It turns into this river of wet concrete that just destroys everything in its path.
That sounds suspiciously like the description in 3 Nephi the storm, the earth being carried up the burial of cities.
It fits the description perfectly. Now, Jordan is careful here. He notes that the Takana eruption seems to have been moderate.
Define moderate.
Think of the Soufriere Hills eruption in Montserrat in the 90s. It devastated the local area, buried the capital city. But it wasn't a darken the whole continent kind of apocalypse.
So Takana might be part of the story, but maybe not the whole story.
Exactly. It validates that eruptions were happening there, destroying cities there at that exact time. But it might have been one of several volcanoes erupting at once, which isn't uncommon, or it might be the local piece of a much larger disaster.
So let's try to synthesize all of this. We have a text, the Book of Mormon, claiming a massive catastrophe with darkness and storms happened around 8034.
Yep.
We have ice cores in Greenland, specifically Camp Century, showing a major volcanic event around 8037, which perfectly fits the travel time.
Right.
And we have a verified eruption at Takana in Mexico in that same window that buried a city in mud.
When you stack it all up, Jordan's verdict is tentative but positive.
Tentative but positive. That's a very careful scientific phrase.
It has to be. The ice cores do not prove the Book of Mormon is true in a theological sense. They can't tell you if people were praying or if spiritual events happened.
The ice doesn't do theology.
No. But what the ice does tell us is that the physical claims of the text are plausible. The vapor of darkness isn't some fairy tale. It's a known volcanic phenomenon. The timeline isn't arbitrary. The Earth really was convulsing during those specific years.
So it moves the account from the realm of impossible myth to historical possibility.
Precisely. And for me, that's the most exciting part of this kind of research. It shows the value of cross-referencing. When we take a scriptural or historical text and hold it up against the hard data of geology, we sometimes find these incredible alignments.
It reminds us that history isn't just stories people wrote down. It happened on a real planet with real people dealing with tectonic plates and magma and climate disasters.
And the record of their suffering, that 3 days of darkness, might literally be frozen in a library of ice at the top of the world.
That is such a cool concept, the library of ice.
It really makes you wonder what else is down there.
That's exactly what I was thinking. We focused on this one event, but think about the invisible ink of history written in those glaciers. How many other legends, how many other myths from cultures around the world were actually just accurate weather reports of volcanic winters frozen in time?
It's the ultimate backup drive for human history. We just have to keep drilling to read the files.
Well, that is a thought to chew on. We're going to wrap up this deep dive here. Whether you're here for the geology, the history, or just the mystery of it all, thanks for listening.
Keep asking questions.
And we'll catch you on the next one.